Hello class, it's now time for the basic Java videos. Here we go. What code segment will print out the hello Carol to the screen in Java? So we're going to start with print lines for most of this unit, and then we'll move into stuff more advanced. So it's very important that we know that the correct format is this. Capital S. This is an L, not a 1, not an I. This will print correctly on two lines, an L, an S, stuff in quotes, hello world. If we just made it print, it would print on one line like this. So we have a little bit of a different editor for the basic Java unit, and this is probably what we'll see going forward. We kind of make a fake Java server for our commands to be printed out on. The docs are a lot different. We'll get into them as we start to learn them. And, well, we don't have our unit tests, but we'll get to them soon. I'm going to make this a little bit bigger so we can see them. Make that a little bit smaller. Our assignments are now over here. We just want to run this, see what happens. It should print once. We can concatenate strings, and this is something I'll need to harp on in class. So I've just made two strings, put a plus between them. Since there's no space, we don't get a space. If I put one here, I'll have one to the left of world. If I put one here, I'll have one to the right, and this will be a double space. Next. Again, we're playing around. Two lines. Remember, if I get rid of ln, like I said earlier, it should be on two lines now. Or a single line, I admit. This is just our first hello world, so we're just going to write a simple system out. And write hello world. Don't forget the semicolon. Oh, I should always remember to check the assignment. We want to print on two lines. It actually wanted us to print our name, but it doesn't really know what a name is and what a name's not, so we can really print whatever we want. See, printing on two separate lines. Just mess around, type some more messages. Get used to type in the command, so it's kind of a first nature thing. This and new are keywords, so they'll get highlighted in blue, but we'll go over those. We'll get to that later in the unit, much later. All right, we'll get rid of that last line just to continue. We'll be good to go, and I'll show you the test cases too. So check code. This can kind of tell if we did something true or not. Here it tells us, did we print on two lines? Yes. It's kind of checking with a Boolean. As we get into more complicated assignments, these will tell you what the difference is between the correct answer and your answer. And this is the art one, not my favorite. You can get the assignment tab over here. We have to print each one a line of this dog on a separate command, on a separate line here. So that means you'll be typing lots of printlns. How many lines are there? 1, 2, 3, 4. Looks like 4. Type 4. Don't put the messages in yet. Just get used to typing the command. Put the quotes in that you'll be inevitably copying into. When we put the quotes, it means that we're putting a string in between them. And the command basically runs each one, runs each string as its own object, and then prints these objects. Now I would start copying, pasting the dog. So we need all the spaces before, and there aren't any spaces after. So copy that first line, Control C, or right click copy, Control V, or right click paste. Start at the end of the line. And yes, it does look kind of janky, but once we actually run it, we'll see that the dog prints. Now let's go over the test cases. It'll compare each line. If we had something different, it would show us where we messed up. So likely you didn't copy all the spaces. That would be my the most common bug I've seen. And see, it says the difference is one space between we're missing. Blah blah. Okay, that's it for 2.1. In 2.2, we're going to be using variables. So let's take a look. We went over this in class. You can watch this one on your own, but let's take a look at the quiz. We want to declare variables and initialize them as well, so with a value. So to do it all in one time, we'd have to have the type, an integer, a name, and what it's equal to. We can of course declare it and then on the next line change the value. What's not a type? An apple. There are no apples in Java. So this was a long example code, I think, but we'll kind of go through it line by line. First, we declare a variable. That's on line 6. And then we print it out with a message before it. And we declare a different one, a double. The doubles can have decimals. Number of YouTube videos watched is printed out of the line after. We declare a string variable, and then it prints out our favorite app. If we were to change it here to, I don't know, CodeHS, run it, we'd see it would change the print line because we just have it referring to a favorite app. Char is the first letter, or a letter. Here we change the value of YouTube videos watched, so YouTube videos watched is declared here. We change it without the type. We can just put a new value, and now this one's updated. Char is yet another type, and we're good to go. Just note that string is declared capital, the other ones are lowercase. Our first integer, so this one is asking us to print what year is it? Current year. If it were the year 2016, what year is it? Please tell me you know. So we're going to declare int the year. And then we have to print it out. Another print line. So hopefully you remember how to type them. Again, it's more practice. We have to kind of get each command in our muscle memory, I would say. It's the first time we need to do concatenation, so let's go through that. We need to type the message exactly the current year is, so now I put a quote right next to the S here, but when we actually do this, we're going to do this, look, and I'll show you the difference. Now we can declare a variable. This is not in quotes. The behind the scenes, this kind of turns each object into a string. This is already a string, so it doesn't do anything, but here this is a number, so it kind of runs the toString command in behind the scenes, which is how the concatenation works and using the variables works. So I have a plus here, meaning I'm adding this string to this string. And let's see what happens when we run it. Current year is, well, there's no space, and if we did our test cases, we'd see that we're missing a space. The red means this is what we're missing. If it was green, it would be this is what we have extra. So I'll show us both. I added a they current year is. See, Y in green means extra, space in red means missing. So we're going to put that space here in this string. It looks a little awkward at first, but you'll get used to it. And let's get rid of that. Check code again. We don't need to output it. We could just do it in our test cases, but output it to make sure it looks good. And we're happy. If we wanted to add something after this, we could. Plus, I want a period after it. Let's make a full sentence. So we put the space here. It's not necessary. We could get rid of them, but it does make it a little bit more readable. Some it doesn't have a period, so it'll tell us this is wrong, and we'll have to get rid of that. You can do that. So assignment over here. What do we want to do? We've already declared these variables. We've had that declared for us. But we don't know the answers to the questions. I mean, we do. They're right here. So what do we need to do? We need to pretty much copy them from here to here, but make sure everything's right. So how do we declare strings? We have a quote. We have quotes around it and a semicolon at the end. They didn't add the values. They didn't add anything else we need to add. We need to make sure that's there. So a string was always declared in quotes. And a semicolon. Lucky number, you fill in. Okay, they left a commented code in there, so if we really wanted to, we could copy each line. But since it's a comment, it doesn't actually get a value, right? This will actually crash, I believe, when we run it. We have a bunch of errors, but yes, here we didn't actually declare anything, so it's an illegal version of the declaration, and obviously we haven't done anything here, here, or here, here, or here, so we're getting errors there. So let's go back to the assignment and fix that. So you fill in, we're going to get rid of that comment, and what's your lucky number? Mine's 42. Current temperature, we have to add ourself, but it's just the same as what we have there. What do we need? Semicolon. True or false? Booleans are always true or false. We want to write true. See, it's highlighted in blue. What happens if we do a capital? Doesn't work. It doesn't get highlighted in blue. So lowercase, when we get highlights, it typically means we've done something correct or done something very incorrect. But since we're looking for true, it's going to be highlighted, and we want that. Let's check our output. Okay, let's check our test cases. Oh, it did actually want 11. That's not my lucky number, but we'll do what they want. Whoop, 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 whoop. .3. What would a program be without the user inputting things? It would be pretty boring. So let's learn how to do that. What was not mentioned in the video? I think it was read char. We're not reading single letters. We could always just use a string for that. What code segment outputs the number 10? If the user inputs the number 10, what will print out? So this means we're printing out a variable, your integer, which has been assigned by this user input. The user's inputting 10. It's going to print out 10, not in quotes. Here's our example. This is going to ask for your name and your age. See, string name is being assigned to a user input, and then it prints out the name. String age, same deal. So my name is Mr. S. My age is Mysterious, and it prints those out for us. Notice if I do 00 for an int, it only prints out the 0 because ints are ints. About us assignment. So this wants us to take user input to ask them and then output the 3 different questions. So that means we're writing 3 variables. These could all be strings, right? So we're going to write and assign 3 strings, and that should be good to go for this. So I sped through that code because it was inevitably repetitive. So we needed to do 3 inputs followed by 3 outputs. So our inputs are read line 3 different times. All of them are strings. They get the read line command. And then we just simply print out the variables. Notice we're just printing out the variables. No bells and whistles, no quotes. The variable matches. If we highlight it, see it boxes it up here. Since it's a variable, it just kind of runs the toString, and these are actually already strings, so it can just print them out simply. Let's run it. What's my favorite food? I don't know, pasta. What's my favorite color? Red. Favorite movie? 2001. And it prints them. Let's check our code. Goes to the test cases immediately. We're missing these spaces. So again, if we're missing something, it highlights them in red. We just need to add them right after the quote. And we will be good to go now. Run it again just to see. Doesn't really matter what we put in there, so I'm just spamming any key, and you can do that too. Submit and continue. This is the poetry. Well, it's not really expecting you to be a poet. You can print whatever you want for this, but just know you have to follow the assignments. First, print out a haiku, so you're going to print out 3 lines. Then print out an acrostic, you're going to print out 5. Then user input, store it in a variable, user output. Let's see what the test cases would want too. We can always take a look to see that, so we can kind of see what we need. You expected correct number of lines 10. Your result 1, and we didn't print anything out. Real quick explanation, this is just writing the same command a bunch, but again, we need to do this to kind of get them into our brains. First is my haiku, 3 lines, 575 syllables. Haikus are real cool, but sometimes they don't make sense. Refrigerator. Very silly. An acrostic is you make a word. If you saw before, I wrote print, and I made it into a poem. Please print a poem right away in the console window. Neat, thanks. And then here's the user input. Now enter your own poem. My poem is, please, no more poetry. This is coding class. And let's check it. Great. We printed the output. We have the correct number of lines, and it printed out the user poem. This is the poem that they put in that we did not. Basically, the test cases kind of apply certain things to do to the code that we've written. If it has user input, checks them, and if it does have the correct output, it's considered good. .4 is math, my favorite. Let's check the quiz real quick. What's the result? So this is the modulo operator that they explained in the video. Basically, it's just a remainder function. 150 divided by 100 is 1.5, or 1 remainder 50. So the remainder is 50. The result will be 50. What's not an operator? Hashtag. We are not tweeting. Example code. This is just showing basic addition. We take the two user inputs as our ints. We're doing read int instead of read line. Then the sum variable is the first plus the second. We print out sum. This could be multiplication. It would print out the product. What's 5 times 6? 30. You get the idea. You could do any kind of calculation you would like. This is the calculator class, so that's what we were in. Tricky Java. In the video that we saw in class, and as we're going to go over right now, when we divide ints, if we have a decimal, and you could see in the comments it's explaining this, it kind of just truncates it. So we have 20 candy bars and 5 friends. If we divide them evenly, they get 4 bars per person. If we have one more friend, we'd have a third extra for each person, but it kind of gets shortened to 3. It kind of gets truncated at the decimal. If we were to change our candy bars per person to a double, it would still round it because these are ints. If we changed everything to a double, so basically we would do an int by an int, and then a double is a decimal, so it just kind of takes that truncated answer and adds a double, a 0.0 to it. So now these are all doubles. Down here, it increases friends by doing the friends plus plus shortcut. This is equivalent to we always assign things based on the values on the right. So if I got rid of this, we'd see the same thing. Friends goes up to 6. And now since they are all doubles, we get 3.33. I don't know why we have a 0.5 there. That's probably due to some weird behind the scenes math that we don't need to worry about now. Area of a rectangle. We of course know that they are length times width. In our assignment, we need to ask what's the width, what's the height. So those are user inputs, and then we should print out the area as a sentence form. So let's do that. Note that these have decimals. So what does that mean? Or it means we're going to be doing doubles. So let's hear an explanation of this code real quick. Notice I've got 2 different solutions here. One's commented out, so we're only running one at a time. But first I declare and then initialize all on the same line. In the second solution, I declare, then I initialize in 2 separate lines each. So it's asking us what's the width, height, gives us the area as a double. We could also put in decimal answers and get back a decimal area. Here I did them as separate as a double area, but in this other method, which I will now uncomment and comment this one in, out, We declare, then we initialize, and then we do the math of the print. There's no area variable. We just have height times width written right into our print statement. And we get the right answer. Check code. Both of these would have worked out, but I've only checked the one. But you can tell that we get the same output, so we would get the same check. Hopefully you can see how we can do two different things to get the same answer now. This assignment's particularly weird in that we have to do math. We have to do math with fractions, but we're left with not actually doing math with fractions. We kind of only really need to know this and this. We're doing addition of fractions, so think back to 6th and 7th grade where we multiplied to get a like denominator, and we multiplied by opposite denominators. That's what we're doing here to actually get the answer. So let's actually look at that in Paint. I think that might be a little bit more helpful too if we actually did the math out. So we have A over B equals C over D. Now if we want this to have like denominators, it would be B times D over A times D, multiplying everything by D, right? And then the other side we'd be multiplying everything by B. Should actually be a plus sign, but you know, still, you get the idea. So we totally agree these have like denominators. B times D equals B times D, right? So when we add them, it's still B times D on the bottom, and then we're just adding the tops. And let's think about that with numbers maybe. Going to multiply by the opposite denominator on each side. So times 4 times 2. Obviously we don't need to do this, but it would always work out, right? And we get 4 over 8. We could just multiply this one by 2 and get 2 over 4. But doesn't matter. We're doing it out proper. 3 times 2 is 6 over 4. And what's our answer? 4 plus 6. A times D plus C times B over B times D. This should also be 8, right? Right. So 12, 8. That would have been our final answer. What do we notice? We didn't reduce it. We didn't simplify it. We did nothing. That's our final answer, and we are happy with it this time. Let's draw a little smiley face. So keep that in mind as you're coding it. We don't need to reduce. We don't need to write anything complicated to handle that. We just need to solve the problem. So let's actually look at the assignment itself. What do we need to do? We need to ask for a numerator and denominator of each of the fractions and then do the addition for ourselves. So first I'm going to put this up here just so we can kind of maybe see the math. Make it a little bit easier just to keep ourselves reminded. So what do we need? We need 4 user inputs, right? And they're going to be ints. So this is where good variable naming and good commenting kind of come hand in hand. So we can say we're doing a math problem given 2 fractions, A over B plus C over D. The sum is A times D. You know, let's use some parentheses. And remember PEMDAS also. So this will always do A times D, then B times C, and then add the values with PEMDAS all over B times D. So that's my planning. We're just going to use A, B, C, D are the values given above. And that's why we're just going to use int A, B, C, D. We could do first numerator, first denominator, second numerator, second denominator as a variable names. But if we have a math problem, let's keep it as a math problem. That's what I say. And we'll put our prompts in a second, but we're going to write 4 of those, and then we'll do the math line. Let's take a close look at exactly what we're going to need to print now. This command's going to get kind of out of hand with the length that we need to have, so let's just take a look, break it down. So we need the sum of, that's going to be one string. We need our first fraction, that's a over d. We need our second fraction, that's c over d. And then this is going to be this math statement here. If we go back to our paint, it's this part in particular. So let's actually take a really close look at exactly how this will break down. So we have our statement string part, and then we need to do a plus this annoying part. So our first fraction, if we want to print out a fraction, we want to do it kind of like this. Our variable, concatenate with a plus, another string for the slash, another plus, then the variable, and then the next part of the string on either side. Very annoying, but it is this box here to get a fraction. So let's get back to coding it. Okay, remember, nice and slow. Here we go. We want to print this line here. That's what this statement's going to be. So I want to zoom out. I'm going to put this as a comment above it. And I'm going to zoom out so we can actually see our coding. We know this is a over b. We're using variables. Variables, 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 variables. And what is this actually? Remember from our paint, it's a times d plus b times c all over b times d. We can't just put bd. That would be looking for a variable called bd, so we have to do the math. So here's the statement. The sum of, concatenate the next thing, our first numerator, plus division, in a quote, plus b. Whew, we're done. That's the first one. Now we do it again for the second one. We're going to want a space between them, correct? We need to add that space. And another plus. C plus fraction plus denominator plus. Now we want the equals, so quote space equals space quote and our fraction, this annoying part here. So just think, how do we want this? We have an equal sign, we have our space. We're going to add something new. We want to add our numerator. A times D plus B times C. That's it. I kind of keep my math tight without spaces. Concatenation with plus another slash, right? plus our denominator, b times d. Now, close it with a parentheses and the line. I think I've done that right, but I've never. We always mess up when we're coding. We never get things right the first time, and that's okay. Sometimes we make mistakes. A simple typo means we just have to revisit our line, change it, and see if we get what we want. So let's run it. Let's go with something simple: 1/2 and 3/4. Looks a little weird, but it's the right answer, right? 2 times 2. It prints it out. Okay, let's check our code, see if the test cases work. We've got a few errors here. And we might have gotten the math a little wrong, but that's fine. Let's just revisit it. So first, we can get rid of the simple error. Maybe if we put some parentheses around it, it would be a little smoother. Actually, solving this might take some weird finagling, but let's take a look at what our output's doing, right? We have 1/5, that's our A and our D. So that would be 1 times 5 is 5, right? And then our B times C is 2 and 2, and that's 4. It's concatenating them, right? So it gets a little bit tricky to do the math in here. So let's throw another set of parentheses around it. Check the code again. And we see it solves it. So what could make this easier next time? Well, my suggestion would be to put this as its own variable. Int new numer for int new numerator equals that whole big A times D plus B times C. And then this just becomes new numer. Does that work now? Let's run our check. Forgot a semicolon here. Thank you, code. Looks good now. So doing math in the print statement might make things a little bit complicated. So possibly consider doing it outside of it.